Hey guys, Mr. Rodriguez here, coming at you on this wonderful Monday morning. So, by this point, when you're trying to try out the back page of the first page of the packet, so like second page, where you have the function that's x value of point and the formal limit, then the alternative limit, um, let's make sure we understand what I'm asking for. So, for the formal limit, I'm asking you to find the derivative of the functions and then take your x value, plug it in, and get the slope of the tangent line formed at that specific point. So the output for the formal limit should be the actual like derivative. So a function you can use to find the derivative at any x value. Okay? So I'm going to do the h of x one because that's the more intense one. And feel free to, well, move things along as necessary. So for the formal definition, it would be the limit as h approaches 0 of the x plus h cubed plus the 2x plus h squared plus 1 minus the x cubed plus 2x squared plus 1 all over h, right? So remember that the formal definition limit, as you can see above, is asking you to find the difference in the y values for any given, for a distance of each a part of the x values divided by that difference itself, because we're trying to get that instantaneous rate of change. We're trying to figure out the equation to figure out any instantaneous rate of change for this function right here. Okay? So we're just going to have to expand this, and I'm going to go ahead and tell you that x plus h cubed should equal x cubed plus 3h x squared plus 3h squared x plus h cubed. All right, and let me explain to you how I know this right here. 3, 1 plus 2 is 3. 2 plus 1 is 3. So whenever you have to expand a binomial like this and it's raised to the third power, right? Technically, each of these variables, if I don't have an exponent, it's raised to the first power. And because I'm raising it to the third power, the sum of the exponents, in this instance, since they're both raised to the first power, should be 3 at all times. This already has a 3. 1 plus 2 is 3. 2 plus 1 is 3. And 3 is already 3. So that's how I get that part. And these multipliers of 3 are just always there. And if you don't believe me, then I highly recommend that you take the time and expand this, right? Think of this as an x plus h multiplying an x plus h multiplying an x plus h. Right? Multiply these two and then take that product and multiply by the third x plus h, and you'll see that you should get the same thing if you did it properly. But continuing onwards, right? Because that's kind of a little aside. Right. So now this would get us the limit as h approaches 0 of x cubed plus 3hx squared plus 3h squared x plus h cubed plus 2 times the x squared plus 2hx plus h squared plus 1. Oh boy. Minus x cubed minus 2x squared minus 1. All of this over h. There we go. So limit h goes to 0 of this mess. Okay, we're almost through. Sorry that my 2's and plus signs aren't super neat. Alright, but we're about to get to the mass extinction right now. So x cubes cancel out, 2x squareds cancel out, 1's cancel out. So you have this term left over, which if you notice, everything has an h, at least one h in it. And we're dividing by an h. So this limit, as h approaches 0, you're going to go ahead and divide every single of the, every single remaining term that you have right now by that h, and that should net you 3x squared plus 3hx plus h squared plus 4x plus 2h. So now when you plug the 0 in for h, we should end up with 3x squared plus 4x. And that's it. So this is what h prime of x represents. This is the derivative. If I plug any number in for x, then that should tell me the slope of the tangent line at that particular place. Right. So now that we have that, we go back. And they were asking us to get the when x is equal to 2. Okay, so we also need to figure out the coordinate point. So no matter if you're using the formal definition or the alternative form of the limit, you need to figure out what the coordinate point of that, like that's on your graph, would be. So we're going to plug the -2 in to the original function. Right, we're going to see that h of -2 is equal to 1. Which again, when you try and find your tangent line, this is your x value, so it's the x sub 1. This is your y value, so that's your y sub 1. And we're going to use the point slope form because it's probably the easiest way to do this. And just so you remember, point slope is y minus y1 is equal to mx minus x1 in parentheses like that. So we already have this, but we still need to find that, and that's where this is going to come in. So we're going to do h of that -2, which is going to equal 3 times that -2 squared plus 4 times that negative 2. Oop, it's prime, don't forget. H prime of negative 2. 12 minus 8. So just to be super clear, H prime of negative 2 is 4. Okay, so as a result, the equation for the tangent line should be y minus, what was it, 1 is equal to 4 times an x minus a negative 2, aka y minus 1 is equal to 4x plus 2 in parentheses. So that's your tangent line equation for that point. So the purpose of this, showing you the alternative form of the limit, is just so, one, I think the algebra might be a little neater, but it comes at a cost. So let's go ahead and run this through again. All right. And let's talk about how this is set up and how you're going to mess with it. Yeah. All right. So remember h of x was x cubed plus that 2x squared plus 1. We're trying to figure out when x is equal to a negative 2. And we previously calculated that h of negative 2 is equal to 1. Okay, that's what we figured out last time. So that's the point on the line, or on the graph of h of x. My bad. I'm just starting to lag a little. All right. So the alternative form of the limit is super specific. All right. So the alternative form of the limit states we're going to find the limit as x approaches. In this instance, it's going to be negative 2 of the function minus the, well, actually the function in this case is h. So let's just go ahead and throw that h in there. H of that specific value, so h of negative 2 over x minus that. Right? So in this instance, we're trying to find the slope of the tangent line at a specific point. So the outcome of this should be a number rather than a function. Right? So it's already kind of doing the substitution at once. Okay? Versus the other one, the formal definition was just having you get the derivative and then plug it in. This is saying, nah, let's just do both at once. So doing so, we end up with the x cubed plus 2x squared plus 1, right? Because that's what h of x is, minus 1 over x plus 2. All right. And so this way you can see that we're going to end up with the limit as x approaches negative 2 of x cubed plus 2x squared over x plus 2, which we can factor into x times an x plus, or x squared times an x plus 2 over x plus 2. Allows us to cancel them out. So then to get our answer, we need to find the limit as x approaches negative 2 of x squared, which just means we have negative 2 squared, which comes out to 4. Which, if you notice, Oops. That's what we found over here as well. We got 4 for the slope of the tangent line when x is -2. All right. But again, the math was easier than everything I've had you do. But the trade-off is if you want to find the slope at only one point on the graph and only one point on the graph, use this alternative definition because the algebra is simpler. But it only works for this particular point, right? Because we only got this by canceling at this stage, and that depended on using the -2 because that's what gave us this right here, and that's the part that allowed us to get rid of the 1 over here. So it's a very specific operation where you can't like extrapolate it and use it, generalize it for other parts, for other points on the graph. So there's your trade-off. So since we know that h of -2 equaled 1, and this means that h prime of -2 is equal to 4, and we know that the point slope is y minus y1 is equal to mx minus x1, where this is your x sub 1, this is your y sub 1, and this is your m. All I have to do is just go ahead and do that substitution. So it'd be y minus 1 is equal to 4 times parentheses x minus that -2, which we can just say that's just really plus 2 right here, since we're recording this and you can see how I'm doing this. So we still got the same answer as the previous step, just a different way. So the big takeaway is just I want to make sure you understand that the alternative form of the limit, while the calculations are easier, if you ever need to find the slope of more than one x value on that curve, you would have to do this for every single x value that you want to do. Versus if you find the formal definition, once you have this right here, right, it's a lot more work, but any x value, you plug that in, it will give you the slope of any point on the tangent line at whatever x value you give it, right? So you can generalize this a little more. That's all I have. Hope it helps. Sorry for rambling. Good luck.